Try to find the critical points of the first function fx equal to x squared. So we have a few steps that we need to do. First of all, we need to differentiate our function here. Okay, find f prime x. So now we can find our potential critical point. How to find it? The first one, we need to find f prime x equated to 0 and then solve for x. Second potential critical point is we need to find f prime x is undefined, which is your denominator, make it equal to 0 and then solve for x. And the third step is we must make sure that our x is within the domain of our function f. Now let's do this. Fx is equal to x squared. So now let's find f prime x. So just use power rule, bring down the power reduced by 1, which is 2x. So we're finished to find f prime x. So now let's find our potential critical point. The first one, let's do f prime x equal to 0. Okay, so let's take this. 2x is equal to 0. Therefore, your x is equal to 0. So keep your answer first. And second step, let's find our next potential critical point, which is f prime x is undefined. So just take denominator, equate it to 0. However, we don't have any denominator, so this is none. Alright, so now the third step, we need to make sure that our x is within the domain of fx. So let's see here, your fx is polynomial, therefore x is all real number. So x equal to 0 is from your real number, therefore we can conclude that our critical point is x equal to 0. Now let's see the second example, fx equal to square root of x squared minus 4. Let's rearrange a little bit. This is just x squared minus 4 to the power of half. So in order to find the critical point, we need to do these 3 steps here. The first one, f prime x equal to 0. The second one, f prime x is undefined. The third one is x is within the domain of f. So let's do this. Let's find our f prime. So this is just power rule. And this is chain rule, okay? So bring down the power reduced by 1, further differentiate inside function. So this is just half x squared minus 4 to the power of negative half, further differentiate inside is 2x. So you can see that 2 and 2 is common term, you can cancel out. Therefore, this is our answer for our f prime x. Now let's find the potential critical point. F prime x is equal to 0. So just take this and equate to 0. Cross multiply this and this results to x equal to 0. So keep this answer first. For the next step, let's find f prime x is undefined, which is let's take our denominator, equate it to 0 and then let's solve. Let's eliminate our square root by taking square of both sides. So x squared minus 4 is equal to 0. x squared is equal to 4, therefore our x is plus minus 2. So just keep our answer here. Therefore, altogether, we have 3 potential critical points. So now let's decide whether we can accept or not these potential critical points, which is we need to check the domain of x and make sure that our x here exists, all right? So now let's find our fx, which is just square root of x squared minus 4 just now. So now let's find the domain for our fx. This is just square root of x squared minus 4. So the domain is the function inside the square root, it must be more or equal to 0. So now let's just factorize this. And then this is x plus 2, x minus 2 more equal to 0. And then let's solve, let's find our zeros. X is negative 2 and x is equal to 2. So now let's draw our smiley graph. Then put in your zeros, negative 2 and 2. So you want a positive 1, so this side here. Therefore, the domain exists only from minus infinity until minus 2 included, union 2 until infinity. Let's check our potential critical point just now. 0 plus 2 and minus 2. So we need to reject 0 because 0 is not within the domain which exists, and then we can only accept plus and minus 2. Therefore, both of them are our critical point, which are x equal to minus 2 and x equal to 2.